Hi everyone, in Algebra 3 today we're going to be going over your questions on lesson 73. To start, we're going to look at number 16, where I'm going to convert this from logarithmic form to exponential form. So this is going to be my L, this is my B, and this is my N. So that converts this to x is equal to 7/4 to the power of y. Now I'm going to make an x and a y chart, where instead of plugging values in for x, I'm going to plug them in for y. So it'll be -1, 0, and 1. Now, 7/4 to the -1 would flip that base to become 4/7, which is just over 1/2. Anything to the 0 is equal to 1, and then 7/4 to the 1 would just be 7/4. So that would be about 1 3/4. So I'm going to graph this. 1, 2. So I'm going to go over about 1/2 and then down 1, over 1 up 0, and then over, that's about 1 3/4. So about here, and then up 1. So this exponential function is going to be a bit flatter than normal, so it's going to look like that. Now moving on to number 17. So for number 17, we are going to have to change something from a sine function, or change the function to a cosine function. I'm going to make it a positive cosine function. But the first thing that we need to do for number 17 is we have to solve for a, which is going to be the midpoint between the top and the bottom point. So our top point is -1 and our bottom point is -5. So you're going to do -1 plus -5 divided by 2. Then B is the amplitude. So that's always top minus whatever you get for your middle line for A. C, we're going to calculate as 360 divided by the length of the period. So the length of the period, I am going to calculate, you could either go base to base, peak to peak, or 1 full rotation. I am going to look right here at -27, where it's hitting its lowest point, and then it's hitting its lowest point again at 189. So the distance would be from 27 to 189. So now, I said it's from 27 to 189, and I can simplify that. So now for the top, I have -1 minus 5 would be -6 divided by 2 would be at -3. Then it's always top minus whatever you get here, so it'd be -1 minus -3, so that would become 3 minus 1, which would be 2. Then 27 plus 189 is 216. So I have 360 divided by 216, which we're going to have to simplify. So 360 written as a fraction. So that's 1 2/3 would be 5 thirds. Okay, so that's 1 2/3, or written as 5 thirds. Now I'm going to start writing this as a function. So y is equal to -3 plus 2 cosine 5/3, and now we're going to do the phase shift. So currently you will see that the function is peaking at 81, and I want positive 81, so I need to shift it back in the negative direction 81 degrees. So my phase shift is 81 degrees. And that would conclude your answer. Now looking at number 18. So number 18 just gives you some of the values, and you just have to rewrite the function. So it says that write the equation of the sinusoid whose graph is a sine function with the center line at -2, an amplitude of 6, a period of 2 pi, and a phase shift of pi over 4. So the equation that we're going to be plugging into for number 18 is y is equal to a plus b sine c of x minus d. Now a is going to be your center line, so that's -2. B is your amplitude, which they give you is 6. C, we have to evaluate. So C is 2 pi divided by the length of the period, which they give us is 2 pi. So that means it's just going to be 1. And then my phase shift is pi over 4. So it's x minus pi over 4. That's your answer. So they give you all the information you need. You don't actually have to draw it or do anything else. So now moving on to number 19, what I'm going to do first is I'm going to multiply the outside numbers and then add the degrees. So for number 19, I get 12 CIS 750, which 750 is greater than 360. So I'm going to subtract 360 twice, which gives me 30 degrees. So this expanded is going to be 12 cosine of 30 plus I sine of 30. Now 30 degrees is going to be in quadrant 1. Adjacent would be √3, opposite 1, hypotenuse 2. So the cosine of this triangle is going to be just 1 over 2. The sine of, the cosine is √3 over 2, my bad. The sine is going to be 1/2 I. And then you just need to distribute your 12. So you get 6 √3 plus 6 I. And that's it for number 19. For number 20, we need to solve for y. So I'm going to eliminate x, meaning that I'm going to multiply the top equation by the coefficient of the bottom equation. So I'm going to multiply the top equation by d. That would be a dx plus b dy equals cd. Multiply the bottom equation by the coefficient of the top equation of x, and I'm going to make it negative, so it'll be negative a dx minus a fy equals negative a g. So my x's are going to cancel, and you're going to be left with b dy minus a fy equals c d minus ag. And to get y by itself, you have to factor it out. Which means that your answer for y is going to be cd minus ag over bd minus af. Now, for number 21, I actually need to use the result from number 20 to solve for number 21. I've written the problems right next to each other so that it's easy for you to match. So notice that a is the coefficient of x, and then they give you 2. So a is going to be equal to 2. B is the coefficient of y, and b is equal to 6. C is equal to the right side, so C is going to be equal to 14. D is the coefficient of x, and the coefficient of x on this equation is 1, so D is equal to 1. F is the coefficient of y, so F is going to be equal to -4, and then G is going to be equal to 8. So all I did was match. coefficient, 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 coefficient equals. Now I'm just going to plug into my equation. So I have C, which is 14, times D, which is 1, minus A, that's 2, times G, which is 8, over B, which is 6, times D, which is 1, minus A, which is 2, times F, which is negative 4. So now I have 14 minus 16 over 6 plus 8. So that means I have y is equal to negative 2 over 14. So it's equal to negative 1 over 7. So that's number 21. So 21 built on number 20. So you have to do both of them in order to get that answer. Okay, number 22, the first thing that I recognize between these two equations is that I can factor out a sine from each of them. So if I factor out a sine theta, what's left inside would be 1 minus 2 sine theta. So I'm going to set each of them equal to 0. So I have sine theta equals 0. Then I have 1 minus 2 sine theta equals 0. If I move the 1 to the other side, it's going to become negative. So I have negative 2 sine theta equals negative 1 divided by negative 2. So I have sine theta equals positive 1/2. Now for the first one, I'm going to use the unit circle because I don't have a reference triangle. That's going to have 0 as, or 0 over 1 as its opposite over hypotenuse. And sine is equal to the y coordinate. So I'm going to underline all my y coordinates. So I'm looking for where the y coordinate is equal to 0. And that would be here and here, to the right and to the left, which means that my answer, my first answer, is going to be 0 and 180. Now for the second one, I need to find where sine is positive. So I have all students take calculus. Everything's positive in quadrant 1. S for sine is positive in quadrant 2. And I have opposite over hypotenuse, which means my adjacents are going to be root 3 and negative root 3. And that means that my angle is 30 degrees. So for quadrant 1, that's just going to be a 30-degree triangle. Quadrant 2, I have to do 180 minus 30, which would give me 150. And these would be your 4 answers. Now, in the answer key, they're going to list them from smallest to biggest. So it'd be 0, 30, 150, 180 would be your answer. Now for number 23, I'm going to start by moving the 4 to the other side. So I have secant squared theta is equal to 4. Now I'm going to take the square root of both sides, making sure you put the plus or minus in front of the 4. So that would be secant theta equals plus or minus 2. Now I'm going to separate that into 2 separate equations. So I can have secant theta is equal to 2. And then secant theta is equal to negative 2. You can always put this over 1. Secant is going to follow the same as cosine. So wherever cosine is positive, secant will be positive. So I'm looking for where cosine is positive. That would be in quadrant 1 and then quadrant 4. Secant is the ratio of hypotenuse over adjacent. So this would be 2 and 1. Now this is going to be a 30, 60, 90 reference triangle. So this is going to be a 60-degree angle. So in quadrant 1, I get a 60-degree angle. In quadrant 4, I get 300. It's going to be 360 minus 60. For my second one, I already know where cosine is positive in 1 and 4, which means it's going to be negative in 2 and 3. So hypotenuse is still 2, adjacent is negative 1. It's going to be the same angle, a 60-degree angle. Because it's in quadrant 2, I need to subtract 60 from 180, which would give me 120. And then in quadrant 3, I'm going to add 60 to 180, which would give me 240. And that would conclude number 23. Now moving on to number 24. What I'm going to start by doing is I'm actually going to set z equal to cosine x, because I have to actually factor this out. So, and I don't want to do it with the cosine in there. So I'm going to set z equal to cosine. So I'm replacing all of the cosines with z. This is number 24. So that would be 2z squared minus 3z minus 2 equals 0. I need to factor this, so I'm going to do a quadratic formula, which would be z is equal to negative 3 plus or minus the square root of negative 3 squared minus 4 times a times c all over 2 times a. So two negatives are going to make a positive, so that would be 3 over 4 plus or minus, this would be the square root of 9 plus 16. So that means z is going to be equal to 3/4 plus or minus 5 over 4. So I'm going to have two answers. I'm going to have z is equal to 3 plus 5 is 8 over 4. That will give me 2. And then I have z is equal to 3 minus 5, which would be negative 2 over 4, and that would be negative 1/2. Now remember in the beginning that I said z equal to cosine. So this is actually cosine x is equal to 2, and then cosine x is equal to negative 1/2. But do I have a reference triangle that has the adjacent as 2 and the hypotenuse of 1? No, we can't. So this one we don't have to solve for, because there's nowhere way for cosine to equal 2. Now I need to find where cosine is negative. So if all students take calculus, I know that it's positive in quadrant 1 and in quadrant 4, which means that it's going to be negative in quadrants 2 and 3. My adjacent's negative 1, my hypotenuse is 2, meaning that my angle is going to be equal to 60 degrees. Because it's in quadrant 2, I'm going to subtract it from 180, which would give me 120. And then in quadrant 3, I'm going to add it to 180, which would give me 240. And those are your only two results for number 24. So you would not have to do the other one. Now looking at number 25, we have tangent squared of negative 690 minus secant squared of negative 690, and then minus cotangent squared of positive 690. So first off, negative 690 is greater than 360. So I'm going to add 360 to that. Would be negative 330. Then same with 690. 690 is greater than 360, so I have to subtract 360, which would give me positive 330. So for the first one, for first two, negative 330 would actually put me back in quadrant 1, with a 30-degree angle. So my adjacent would be root 3, my opposite 1, my hypotenuse 2. Then positive 330 would put us in quadrant 4 with a 30-degree angle. This would be root 3, negative 1, and 2. So for the first one, tangent is opposite over adjacent, and that would give me 1 over the square root of 3, and I'd have to square that. Minus secant is the inverse of cosine, so that would be hypotenuse over adjacent. So that would be 2 over the square root of 3, and I'd square that as well. Then cotangent is the opposite of tangent, so instead of adjacent, opposite over adjacent, it's going to be adjacent over opposite, which would just be negative root 3 squared. Now that result is going to give me 1/3 minus 4/3 minus 3. So really I end up with negative 1 minus 3, and my result would be negative 4. And that's number 25. Now looking at number 26, I am going to start by just inputting my f and my g functions in. So for number 26, I get cosine squared of pi over 4 plus sine squared of 3 pi over 4, and then times cosine squared of 5 pi over 4. So now I'm going to make my snowflake chart for over 4. So 1, 2, 3, 4. 1, 2, 3, 4. Starting at 0, I'm going to count to 1. That would be in quadrant 1. So the first one is going to be a triangle in quadrant 1, 45-degree triangle, 1, 1 root 2. Cosine is adjacent over hypotenuse. Second one, 1, 2, 3. That's going to be a 45-degree triangle in quadrant 2. So negative 1, 1 root 2. And that's opposite over hypotenuse. Then the last one, 1, 2, 3, 4, 5, puts me in quadrant 3. Also with a 45-degree angle. So negative 1 root 2. And cosine is adjacent over hypotenuse. So for the first one, I have adjacent over hypotenuse, which will be 1 over root 2. And I'm going to square that. Second one is going to be opposite over hypotenuse, which is going to be 1 over root 2, squared as well, times the cosine of the next one, which is adjacent over hypotenuse, which would be negative 1 over root 2 squared. So really I have 1/2 plus 1/2 times 1/2. Make a common denominator. So that'd be 2 over 4 plus 1 over 4 would give me 3 over 4. And that's number 26. Now 27, I have a circle in the top one and then a line in the bottom one. So for the first one, it's going to be centered around 0, 0, and the radius is going to be 4 because of the 16. So the radius is 4, centered at 0, 0. So this is going to be your circle. Okay. And then the second one is going to be minus 2, so down 2, and the slope is up 1 over 1. So it should just be a dotted line like this. Okay, so if it says that it's less than the radius, that means you're going to shade everything inside of the circle. So less than the radius means inside the circle. So I'm going to shade everything inside of the circle. And then when it says y is greater than the line, that means that's everything above the line. And in that case, it would be everything above here. Which means your result is the section that's covered by both. And in that case, it would be the section inside the circle, but above this line. And that's how 27 would look. Now for number 28, I see that there's a number outside my logarithm, so that is going to become the exponent. So that becomes ln of 27 to the 1/3 plus ln of x squared equals ln of 2 minus x. I'm going to combine the left side because of the plus sign, so that's going to be ln 3x squared equals ln 2 minus x. To get rid of the ln, I'm going to raise both sides to the power of e. And that would give me, if I set it equal to 0, it would be 3x squared plus x minus 2 equals 0. To solve for x, I have to set either do the quadratic formula or do completing the square. So x equals negative b plus or minus the square root 1 squared minus 4 times 3 times negative 2 all over 2 times 3. So this would turn into 1 plus 24, which would be 25. So really I have negative 1/6 plus or minus 5 over 6, because the square root of 25 is 5. Negative 1 plus 5 would be 4, so 4 over 6 is 2/3. And then negative 1 minus 5 would be negative 6 over 6 would be negative 1. But if you go back to the original problem, you can never take the log of a negative number, so it cannot be ln of negative 1. So therefore, your only answer is going to be 2/3. Now looking at number 29, I am going to multiply the left two values together. So I have log of 8 of x minus 2 times x minus 3 equals 1/3. To get rid of the log 8, I'm going to raise both sides to the power of 8. The left side is going to turn into x squared minus 5x plus 6 is equal to 2, because 8 to the 1/3 is equal to 2. If I set this equal to 0, I have x squared minus 5x plus 4 equals 0. That factors evenly into negative 4, negative 1. So my two answers would be x is equal to 4 or 1. But if I take this 1 and I plug it back into the beginning, 1 minus 2 is negative 1, and you can never take the log 8 of negative 1. So therefore, your only answer is 4. Now lastly, number 30. Use the locus definition method to find the equation of the line equidistant from negative 6, 4, and 4, 9. Let's see if I can squeeze this in here. So equidistant or locus definition is the x minus x1 squared plus y minus y1 squared. So I'm going to do x plus 6 squared plus y minus 4 squared equals x minus 4 squared plus y minus 9 squared. You do need to multiply the whole thing out. So it would be x squared plus 12x plus 36 plus y squared minus 8y plus 16 equals x squared minus 8x plus 16 plus y squared minus 18y plus 81. Slope-intercept form is y equals mx plus b, so I'm going to cross out the x squareds and the y squareds on both sides. And I also see that there's a positive 16 on both sides. Those would actually cancel too. I'm going to move all the y's to the left and the x's and whole numbers to the right. So I'm going to move the 18y over to the left, move the 12x to the right, move the 36 to the right. And that would give me 10y equals negative 20x 81 minus 36 gives us 45. Then I have to divide everything by 10. And that would leave me with y is equal to negative 2x plus 9 over 2. And that concludes your questions on lesson 73. I hope you guys all have a great day. Bye.